Good afternoon. Today we're going to be talking about parallel line proofs. So this is actually part of lesson 3.3, but it's also an introduction to 3.4. So today we're going to do a couple of flow proofs. So it's the same logic and reasoning that we used in the previous chapters, except the format's just a little bit different. So if we look at what's going on here, example 1, we have a proof and we have our given and we have our prove, but the format looks just a little bit different than in the previous sections. So if we look at what we're given, we are given that line A is parallel to line B. So when we look at the fact that line A is parallel to line AB, that means that we have some congruent and supplementary angle pairs going on in our picture. So if we look at the steps they are given, right now in this picture, step 1 right here, they tell you that angle 2 and angle 3 are a linear pair. We know this from a previous section, and it's going to be just the linear pair postulate. So instead of actually having a given and a prove, or a statement and a reason column in our proof, we just do a little flow proof here, and we write the statement in a box, and we just put the reason out to the side. So then, what does the linear pair postulate tell us? Well, if we have a linear pair, we know that the angles are supplementary because the definition of linear pair is adjacent supplementary angles. So just like before, when we use the definition of, right here we have a linear pair, so we know that angle 2 and angle 3 are supplementary by definition of linear pair. All right, well, what does it mean to be supplementary? If we look at the next step, supplementary means two angles whose sum is 180 degrees. So basically, this comes from the previous statement, so we have definition of supplementary angles. And once I have that, I really can't go any further along that path, so I'm going to come up here to the next column, and I'm going to follow the path here. So A is parallel to B. So if you look back up at your original problem statement, it says that A is parallel to B. So just like before, that is a given statement. Not sure what happened to my arrows here. All right, so if A is parallel to B and I look at my pictures, the next statement says angle 1 is congruent to angle 2. So if I look at my picture, here's angle 1 and here's angle 2. When I look at angle 1 and angle 2, one is interior, one is exterior, and they're on the same side of the transversal in corresponding locations. So they're corresponding angles. So angle 1 is congruent to angle 2 because if A is parallel to B, then corresponding angles are congruent. Now, from the previous chapter, when we go from something that has a congruent sign to something that has an equal sign, so we have congruent angles which have equal measures. That's going to be definition of congruence. And that's as far as that path will really take us. So now is when my two paths merge. On the left, I have that angle 2 plus angle 3 is 180 degrees. And on the right, I have that the measure of angle 1 equals the measure of angle 2. Well, if you look back up to the original problem, we're trying to prove that angle 1 plus the measure of angle 3 adds up to 180. Well, over here on the left, I have the measure of angle 3, and I have 180, but this measure of angle 2 really needs to turn into a measure of angle 1. So if I look over here on the right, I know that angle 1 is angle 2 equals the measure of angle 2, so I can simply take out angle 2 and replace it with angle 1. And when I take something out and I replace it, that is going to be substitution property, just like a substitute teacher. And that is basically the gist of a flow proof. So same logical reasoning as a regular two-column proof, the format is just a little bit different. All right, so let's take a look at example 2. So in my givens, I am given in example 2 that line A is parallel to line B, and I'm given that line C is parallel to line D. So what does that tell us? Well, when I go to look at my flow proof, they have given us the first two statements, so I'm going to go ahead and mark those as given. So I know that A was parallel to B, and I know that C was parallel to D because those were given. So if I look at line A and line B, and I look at the angle pair that's formed, here's the angle pair that's formed by line A and line B. So when I look at those are both interior angles, and they are on opposite sides of the transversal. Because the lines are parallel, I know that those two angles are congruent. So I know those are congruent because if A is parallel to B, then alternate interior angles are congruent. Now that I have a pair of congruent angles, I'm really, when I looked at the fact I'm trying to prove angle 1 and 4 are congruent, I'm just kind of at a dead end right here. So I'm going to go over to the process on the right, and I'm going to look at line C and line D. So when I look at line C and line D, line C contains angle 1, and line D has angle 4 right here. And when I look at angle 1, or like angle 3, sorry, when I look at angle 1 and I look at angle 3, one of those angles is interior and one of them is exterior, and they are in corresponding locations. So if C is parallel to D, then corresponding angles are congruent. All right, so now on the left-hand side, I have that angle 3 is congruent to angle 4. And on the right-hand side, I have angle 1 is congruent to angle 3. So if 4 is the same as 3 and 1 is the same as 3, then I can conclude that 1 is the same as 4. And this is the transitive property. All right. So you have a couple flow proofs on tonight's homework. So they give you the statements and you just have to follow up with the reasons, but really look at the pictures and internalize what's going on, because tomorrow you are going to have to do the whole proof by yourself. Have a wonderful night, and we'll see you in class tomorrow.